Hello, mathematicians, and welcome back. Today we're discussing problem number 5 on page 102 of Math and Focus, Course 1, Textbook B. This is the practice for Chapter 10, Lesson 3, number 5. So you see in front of you this yellow hexagon, right? And this is a floor tile. So we're told that it's in the shape of a regular hexagon, and as you know, a regular polygon is one that has sides that are all equal to each other and angles that all measure the same, right? So this is a regular hexagon, and that means that there are 6 equal triangles formed by each side of the floor tile when the line is drawn to the middle. So let's go ahead and show a few of those. Here we go. Here we go. So these hexagons, if you were to draw one to each, and it's aligned to each vertex, right? Then you would have 6 equal triangles. And these are what we're going to use to help solve our problem. All right. So we're further told in the problem that Greg has used 187 and a half of these tiles to tile a room, and the area of the room is 450 square feet. We need to find the length of each side of the hexagon. Now, it is possible that you looked at the 450 square feet and you said, oh, that's the area of the hexagon. No, that's the area of the room. And Greg needed 187 of the hexagons in order to tile it. So it's important to make sure that you know exactly what you're thinking of, all right, when you see this information given to you. And you'll see underlined in dark blue on the problem is our question mark. And our question mark is this piece right here. Oops. All right. That what is the side length of each of the sides of the hexagon? That's our question. All right. So let's take the information we know. And that would be that the room is 450 square feet. And Greg used 187 and a half tiles. Okay, so if I divide the square footage of the room by the number of tiles he used, then I wind up with the square footage per tile, all right? So each of these hexagonal tiles is 2 4/10 square feet. And I know that there are 6 triangles within that 2 4/10 square feet. So to find the area of each triangle, all I have to do is divide 2 4/10 by 6, because there are 6 of these regular triangles within the regular hexagon, okay? So when I do 2.4 divided by 6, or 2 4/10 divided by 6, I get 4/10. All right, and this makes sense because 24 divided by 6 is 4, and 2 4/10 divided by 6 is going to be 4/10. All right, so at this point, I have 4/10 as the area of my small triangle. And this is good because I know the height of the small triangle, but I do not know the base. So to help me figure out the base, which is what I'm looking for, I will take the area. Let me put the formula up. That would be area, is 1/2 base times height. Right? So if my area is 4/10, and that is half the base times the height, and I know that the height is 0.8. Let's go ahead and put that up there. All right, now where did I get that 0.8 from? Well, I was surely told that up at the beginning of the problem. It's right here. It's written on the problem, right? A height, I find the height when I look at that perpendicular line that's dropped from the opposite angle to the base. So let's see if I can, do I have the ability to make a, guess I can't make a box. Oh, I can make a box. Here we go. Here's the opposite angle, right? And here's the base. All right. So that line that's dropped perpendicularly to the base from the opposite angle is the height. And you know this, you've been doing this many, many times. All right. So, so now at this point, we have this formula that's partially filled in. All right. And I'm just going to do a little bit of rearranging to try and get things, you know, in some sort of shape to be able to use. So I have my area, which is 4/10. And instead of having the base first, I'm going to put the base last. So I have 1/2 of, let me put my multiplication sign up there, 8/10, whoops, times the base. Okay, and just as surely as you're sitting there and I'm sitting here, I know that 1/2 of 8/10 is 4/10, right? So 1/2 of 8/10 is 4/10, you know that, times the base. Now at this point, all I have to do is divide each side by 4/10. Let me tab on over there. Oops, can I do that? I guess I'll just have to do this way. Don't pay any attention to that period that got put there. Okay, and I will put a line under that to indicate division. Here we go. We're going to divide each side by 0.4 or 4/10, and that is going to get this variable b all by itself, all right? And that's what I want. When I divide this, they drop off on this side. And so 4/10 over 4/10 is the same as 1, right? So I have over here 1 equals b. Oops. Sorry. I'll go ahead and write it in. 1 is equal to b. All right, so my base is 1. All right, so now at this point, I can go ahead and I can try to figure out what the area of the whole thing is. So this is just a matter of checking myself. Sorry about that alarm. So I'm going to multiply just opposite, right? So if I do 1/2 base times height, and that's 1 times 8/10. I get 8/10. I take half of that. That's 4/10. So my area is 4/10, and I have, let me change colors here so I can check these off as I go along. Okay, 1/2 base times height, I'm substituting in here. The base being 1, the height being 0.8, as I was told. So 1 times 0.8 is 0.8. Half of that is 0.4. And that is our area. So the area is good. And if I take 6 times 4, I get 2.4. And that's the area of the entire hexagon. And when I multiply 2.4 by 187.5, I wind up with 450 square feet. And so I've been able to reproduce it by going backwards, and I'm done. The base is 1. And we've answered the question that we were originally asked. All right, that's it. Talk to you later.